Alright, for this screencast, we're going to do something pretty complicated. Well, it's easy to implement by hand, but it's complicated to do in code. It's called Romberg integration. So Romberg integration essentially says integration. It computes the trapezoidal rule for multiple values of n, and then computes the column. Say I want I of 1 comma 4. That means I want to compute the fourth order equivalent of the integration of my function. So basically, it really just needs one input, and the input is n order. And so the idea is that we want to compute I of 1 comma order, which means that our matrix, so I'm going to call it Ri, is zeros of the number of rows is equal to n order, and the number of columns is also equal to n order. All right, so the first step is to compute the first column of Ri. So we're going to say for idx equals 1 to n order. We're going to say Ri of row idx comma 1 equals my trapezoid, and we're gonna write this in a sec of, and now what we need is a base n, and what we're going to do is we're going to do idx times base n. And so now what we're going to have a function down here called essentially I equals my trapezoid of n. And then we're going to say for idx, so now we need to compute dx. So we need to figure out what we're integrating. So I need a function y equals f of x. So I just like to do pi because it's easy. So y equals square root of, and I'm gonna throw in a 2 in here to get pi, and I'm gonna say 1 minus x dot hat squared. So then my bounds b is 1 and my start is -1. So then dx is b minus a over n, and that's my dx. And then so I'm going to say for x equals a to dx to b, and remember you have to go minus dx. That way you don't overestimate. And then you just do the trapezoidal integration. So I is 0, and then I equals I plus 0.5 times f of x plus f of x plus dx times dx. Okay, so then that should give us our first row. So if I just put out Ri here, and actually I'll just make it return in the function. So I'll go up to the function header and I'll put Ri equals this. So I should be able to do Ri equals Romberg integration, and I'm going to do I want I 1 comma 4, and I'm going to say my base n is 10. So there we go. So my first estimate of pi is 3.03. My second estimate is 3.1045, and then as you can see, as I increase n, I get more and more accurate. So now what I need to do is I need to fill out the rest of the columns here. So I'm going to say, let's just do this generally. Let's say I want to fill out the second column, right? Well, what you would do is you need to take this guy, and then you need to use that formula from Sakai and combine them together. And you want to only go to the n order minus 1. So you're going to say for idx, or I'm going to say a row equals 1, 2, and in this case I'm going to say n order minus 1. And then I'm going to say Ri of, what is it? What row am I on? I'm on row, column 2 equals, and then I need to take a combination of, it's going to be 4/3. And actually here, let me look up the equation real. Okay, so I've got the equation here pulled up. So it is let's see, it's not 4/3. It's actually 4 to the k times, and then it's ri of, and then this is a row plus 1 comma 1 minus ri times row comma 1, and then all of this divided by 4 to the k minus 1. And then the question is, what is k? Well, k in this case is 1 because it's the second column. Okay? So I'm going to go put this away. That's all we need. And so now we should, if we run this, now we should get a second column with more accurate results. So I combine these two guys and I get this guy. That's more accurate than these two, and then these two I get this guy, which is more accurate, and then these two, which is more accurate. So now what I need to do is essentially move to the third row or the third column, but it's essentially just the same thing over here. So what I want to do is I actually want to say 4 column equals 2 to n order, and I want to move this all over. And then now I have a way to loop through the columns. So now I need to make sure all of this still works. So I start at row 1 every time, but I actually go n order minus the column number plus 1. And then k is not actually 1, it's the, again, column number minus 1. And then here, it's not row comma 2, it's row comma column. 4 to the k is fine. Again, here it's not row plus 1 comma 1, it's column minus 1. And then here it's not row comma 1, it's column minus 1. And then here we're fine. Here we have 4 to the k. So now we should be good to go. That should be it. So we should get, every time we shoot over, we get a more and more accurate representation. And there you go. So here's 3.1311, which is more accurate than 3.1285. If we make our base n larger, again, we've got, 3.1369. Here we have 3.1379. And so there's Romberg integration making our numbers more and more accurate as we move to the right. If I do, say, 5, now I've got an extra row over here that gets me more and more accurate. And there you go. There's Romberg integration. It's pretty tough to get that all to work, but it's only a couple decade lines of code. All right. Good luck.